Go. All right, we're gonna fix a VEX battery today, and here's our things that we need. We need some flux. We need a soldering gun. We have a battery that's broken. Some needle nose pliers, solder. We may need some copper braid wire, electrical tape, and our multimeter to test it when we're done. Set a couple of these things to the side. Here's a battery, a typical battery that's broken. You're going to find that they're either broken fully at the wire here, or sometimes the wires are in here, but they're just frayed and loose, and maybe the electricity is jumping across them, so we need to repair it. This is a new battery, so on this one I would get a box cutter, and I would cut around this seal right here, trying to take the blue off, and underneath what you'll find is a black cap like this. We'll remove the black cap and then hang on to it because we want to use that later. When we're done, since we took off this blue seal, we'll replace this seal with black electrical tape to keep it nice and neat, okay? So here's one that I've already removed the seal, and I've disconnected the wires. Make sure to maintain as much of the wire length as possible. Can you pause it for a sec? Yes, ma'am. So keep as much of the length of the wire as possible. Don't like trim it halfway, or that we like shorten the ability of our battery to reach the cortex. So keep the length, strip your wires. You don't need much, and there's a lot of braid to these wires. So I would twist them to keep the braid intact. You can see here the braid that's still attached to the two prongs, and there's a lot of solder on these, right? To work with this, I would extend these two prongs all the way out here, so you don't actually come down here and solder the batteries themselves, because you can burn the battery, you can burn the paper that the battery is wrapped in. And then I would come up with some type of a system. I have a ton of textbooks next door. I would take a book and I'd stack it right here, and I'd take a book and stack it right here, and it's going to hold your battery upright so you can work with it a little bit better, okay? For right now, I'm going to use my lovely assistant, and she's going to hold the battery as she films, because she's multi-talented here, all right? So the first thing we need to do is we got to get rid of all this excess solder and the old braid. So I'm going to heat it up. Hopefully my soldering gun is hot. I had it plugged in. I'm going to make sure I grab all the braid so that when the solder melts, we've got the ability to just remove this whole braid. I tried to do this at home last night by myself, which was a little tricky to film and solder at the same time. And I couldn't get the soldering gun to heat up at home. I don't know what the deal is. And this one may not cooperate either today. I keep getting bad soldering guns. You guys know how to solder though, so that's not that hard. There we go, it's coming. Okay, ready? So it's melted, and then I gotta get all of my copper off, okay? I'm gonna go ahead and do the other side too, flip that over. I got my soldering gun hot. If you need to, you can apply some pressure behind it, right? So we can get good contact. Don't over solder these. It becomes really messy and reduces their ability to conduct the electricity efficiently. All right, I'll set my soldering gun. Thank you, Vanna. Good job. Do you know who Vanna is?
No.
No, that's okay. All right. All right, I don't have too much solder here. This is going to work just fine. So now I got to reattach my braid wires. I think I have enough solder on here that this is going to work, so could you hold this again for me, please? It does not matter which side that I attach it to. Okay, if these are dual current batteries, so it can flow either way, that's just fine. So I'm going to go ahead and put my wire on the solder here. I'm going to heat up through the wire. This wire is going to get hot, okay, as the heat's traveling up through it. It's not a big deal. It's meant to handle a lot of temperature. It's got the rubber around it, but don't go down and touch the wire because it's going to be pretty hot. Okay. Okay, so let's pretend that I did an awesome job soldering that, and I did an awesome job soldering the other side. Amazing, the best soldering job you've ever seen. If you need to, you can add a little bit more solder to it to make it nice and solid. You want to cover up as much of the braid as possible. You don't want any like loose wires hanging out, okay? So it's connected here now. We want to take a little bit of our electrical tape and wrap it around our new formed joints, so that we don't have any additional fraying. Why do you guys think that these batteries need so much repair all the time? How do you guys always carry these batteries around? By the cords. Do you ever notice that? You just grab the cord and you swing it around. Yeah, okay. So that's why they need a little bit of extra support. So this is soldered here. We would then add in some electrical tape around it to hold it in place. And this also helps us so we don't have any electricity that might jump across it. So both would be wrapped with electrical tape. Then we would pull our cap back down on the top, press these down flat. Another reason why we have that rubber there to stop them from jumping the current. We get our cap on, tape our cap on nice and tight, and then we can test it with a multimeter at the end to make sure that the flow of the electricity is good. So we're going to turn on, we're just checking voltage. We're going to turn it to 20 volts. These are 7.2 volt batteries. And it says right on there, if you're ever testing a battery. So you put the voltage to the number that's within the range and above. So I wouldn't put it to 2 because 2 is not above. 20 is perfect, and it gives us the most accurate measure here. This one you do want to connect the correct wiring. So we would do red to red and black to black. Looking inside of our battery prong, it's a little tricky to get these touching, okay? And right now, we're not going to get a reading at all because, remember, I didn't actually get these soldered. But when these came through, we should see a reading somewhere under 7.2, unless the battery's completely dead, and then it might be 0. But most of these batteries hold a little bit of charge even when they're technically dead. So we'd see anywhere 6.7, 7.1, and we'd see that voltage. Okay, this is how you test voltage on any battery, and you can see how much energy is left in the battery. You'd see that voltage decrease in number as you test it and use up the energy. Okay, be careful with the soldering irons today. If you get burned, talk to the teacher. We have ice next door. And do a really good job of adding on the electrical tape so that no wires in here actually would touch across each other. Otherwise, these batteries are not going to work, and you're repairing batteries. Every battery repair saves us $29, and every motor repair saves us $39. So between the two classes today, we're going to repair $2,000 worth of robotics equipment that we can then spend that money on something else. So that's awesome. Your goal is one battery and one motor by the end of the period.
Okay.